So now we want to look at the identity matrix, usually denoted by the letter I, capital I. So the identity matrix is a square matrix, so square, same rows, same amount of rows, same amount of columns, right? That has ones along the leading diagonal. So for example, we're looking at the case with a 2 by 2. So 1 along the leading diagonal and 0 elsewhere. Good? So the leading diagonal descending from left to right. So this is the identity matrix and we call it I. That's the identity matrix for the 2 by 2. Just interestingly, for the 3 by 3, it will look something like that. 3 by 3, you have 3 rows, 3 columns. So it will look 1 and then 0 elsewhere, right? Good. That's the example of our identity matrix for the 3 by 3. But we are focusing on the 2 by 2 for this lesson. Alright, so now the term identity, when we talk about identity matrix, is the same idea as the number 1. So we now say, for example, you have the number 1. If I say what's 1 times 6, then the 1 times 6 is 6. The number remains unchanged. In the same way, if you multiply I by any matrix, say A, then you still get A. The matrix A does not change. The elements remain the same. Good? Let's show you a practical example. Right, so suppose we have a matrix. We have a matrix B. And let's say the matrix B is 4, 7, 8, 5. And we're asked to find IB. So I usually use 1, 0, 0, 1 times B, and B is 4, 7, 8, 5. So if I multiply these two matrices, so you apply, or you remember the multiplication, you apply 1, 0 to 4, 8. So row by column. So 1 times 4 and 0 times 8. So 4 plus 0, which is 4. Then you apply 1, 0 to 7, 5. So 1 times 7 plus 0 times 5, that's 7. Then you apply 0, 1 to 4, 8. So 0 times 4 is 0 and 1 times 8 is 8. And you apply 0, 1 to 7, 5. So 0 times 7 is 0 and 1 times 5 is 5. Notice the matrix you get is still B. So I times B is equal to B. So it's the equivalent of multiplying by 1 per se. Alright? The value does not change. And now even though matrix multiplication is not commutative, so earlier we did IA. What if you have a matrix B, and let's say B is 2, 7, 4, 1, 2, 7, 4, 1, and you're asked to find IB. Then IB would be I times B, right? So it will be 1, 0, 0, 1, that's what I is, for the 2 by 2, and 2, 4, 1, 1. Then what you'll end up with is 1, 0 times 2, 1. So 1 times 2 plus 0 times 1, so it's 2. Then 1, 0 to 4, 1. 1 times 4 plus 0 times 1. Then you apply 0, 1 to 2, 1. So 0 times 2, 1 times 1, we get 1. Then you apply 0, 1 to 4, 1. 0 times 4 plus 1 times 1, so it's 1. So you end up with B. So IB, same as B. But what if you're asked now to find BI? Alright. BI, you multiply B, so B was what again? 2, 4, 1, 1 times I, which is 1, 0, 0, 1. Let's multiply these. So row by column, so you apply 2, 4 to 1, 0. So 2 times 1, 2. 4 times 0 is 0, so it's just 2. Then you apply 2, 4 to 0, 1. So 2 times 0, 0. Plus 4 times 1, 1. So it's 4. Then you apply 1, 1 to 1, 0, we get 1. And you apply 1, 1 to 0, 1, you still get 1. So whether it's I, B, or you still end up with B. So in this case, it's commutative when you're using the identity matrix. IB is BI. So in the same way, AI is IA, and so on and so forth.